It is now time to get started. Hi all, my name is Diego May, Chief Revenue Officer at InOrbit, and I will be your host today. Welcome all to this webinar on scaling up your robot fleet with RobOps. As you know, InOrbit works with industry leaders in the robotics space, solving problems from robot connectivity to data observation, orchestration, and operation. You're here, and that means that you care about scaling a fleet of robots. And that is what we're going to talk about today. We will talk about some of the best practices to scale from 5 to 5,000 robots. However, not everyone is at the same point in this journey. And to get a sense of where the industry is today, please fill out the survey you should have now in your screen. And of course, we will share those results in a follow-up email afterwards. The question in the poll is about how many robots you have deployed. While you complete the survey, a couple notes before we get started. First one on questions. Think of this as a gathering of friends really interested in scaling robots. Your questions are very relevant, so please share them via chat. I'll be sure to take notes of all those questions, and hopefully we can get them answered in the Q&A section at the end, or we will follow up later to ensure that you get the answers for your questions. The second point on our next webinar, it will be about RobOps and logistics, and it is scheduled for Wednesday, May 26th at the same time. So we will follow up later with additional details. I'm closing the poll in a few seconds, so if you have not yet voted, now is the time. 3, 2, 1. Okay, poll is over. So, to get started, let me pass it on to Florian Pestoni, InOrbit's co-founder and CEO. Florian, the floor is yours.
Thank you, Diego, and thanks everyone for taking time out of your busy schedule to attend today. We have an information-packed session, so let's dive right in. The first thing I want to mention is that as we talk to companies in different industries across logistics, retail, building services, we're seeing some recurring challenges. And many of these predated the pandemic, but were exacerbated over the last year by changing consumer habits, labor conditions, and the need for flexibility. So one answer to this is automation, and since we're all here today, I probably don't need to convince you that automation can help operations. But perhaps less obvious is that automation also requires operational processes to keep it optimal and to keep that virtuous cycle. So we're going to be talking about robot operations, which is an emerging area in robotics, something we call RobOps for short. And this is a little bit of a wink to DevOps, which you're probably familiar. RobOps is all about creating the best practices and support tools to manage robots at scale. Now, a RobOps system like InOrbit can handle a couple of areas. One is problem detection. How do you know that something is wrong? Notification. When something is wrong, who gets alerted? And then resolution. How does somebody fix the problem and get the robot back to a working state? Perhaps more important than all of these is getting the necessary data to drive continuous improvement, which is really critical for efficient operations as the fleet starts to grow. So one aspect of robot operations or RobOps that we're going to focus on today is the human factor. So a robot operator, which we refer to as a roboteer, is needed to take care of situations outside the range of autonomous operation of the robots, often due to the chaos of working alongside people or in uncontrolled environments where robots may operate fine most of the time, but not all the time. So we call these autonomy exceptions when they occur. And then a roboteer may be working next to a robot and may be able to take action directly, or they may be connecting remotely from a robot operations center, perhaps in a different continent. So for the next part of our presentation, I'd like to introduce John Simmons. who's InOrbit's Director of Product Management and an expert in robot operations at scale. John?
Thanks, Florian. I'm really excited to be here today talking about the challenges that our customers face when they're trying to scale to hundreds or thousands of robots. And I know a lot of you in the audience are going to have some questions as we go over this journey today. Please post them into the chat. And as Diego said, we've got some time at the end for Q&A. We'll try to get through them all. And if not, we can follow up with you later. Also, I'd love, if you're interested, for you to reach out and connect with me, John, at inorbit.ai. And I can set up some time, or we can set up some time to talk about these concepts in more depth as it relates to your particular solution. Okay, so let's get started. First and foremost, scaling robots is a journey. And like all journeys, this journey has different stages, different characteristics at each stage, different challenges and goals. And today we're going to talk about this journey really from the perspective of an operations team. And partly because NASA and SpaceX have been in the news so much lately, partly just because I think rocket launches are fun, I'm going to describe these stages in terms of a rocket launch. Okay, so let's get started. The primary stage, we need to get this rocket off the ground. We've got 50 robots we want to deploy. Getting beyond the initial deployments into the primary stage can be incredibly difficult. And personally, I find this one of the most challenging areas. It can feel like you're just not making any progress in this earliest stage. That's in large part due to what I like to call the dirty little secret of autonomous robots. And the dirty little secret of autonomous robots is that they're just not all that autonomous. In this stage, that reality is front and center day in and day out. Autonomy exceptions, those issues that Florian mentioned earlier, they're through the roof, maybe 20 or 30 per robot a day. At 50 robots, that can be 1,000 autonomy exceptions. Incidents where someone is having to respond in some way to a robot. That drives very high touch time from your operations and probably engineering teams as well. And out of necessity, just to keep things running. And since no discussion of operations is really complete without talking about costs, let's talk about the cost of those autonomy exceptions. So imagine just the time to respond to all those exceptions. Your support infrastructure is probably going to exceed at least $600 per robot per month. At 50 robots, that's about $30K a month. And at this stage, it probably seems manageable, but let's set that aside for a little bit and we'll circle back to it later. Okay, so getting back to getting off the ground. Your robots aren't as autonomous as you'd like. Your engineering team and your operations team are really busy day in, day out, dealing with a lot of symptoms of problems, having trouble getting to solving the underlying issues. What now? Florian mentioned earlier the importance of RobOps principles on a scaling robotics effort. And the first of those principles is called systems thinking. You DevOps geeks out there probably know this as the first way. Systems thinking means you need to understand the end-to-end solution. That goes much beyond understanding just the robot, which may feel complex enough on its own, but to understand the environment that the robot is operating in, the customer expectations of the robot, your job inputs and result outputs, escalation procedures, and support processes. And these may be being performed by a remote operations center, or they may be being performed by warehouse operators or other facility operators who are closer to the robot. But what's important to remember is that that work must be done somewhere. All of these responses, and understanding the system that it happens in is really, really important to start to make progress to stabilize the solution. It's only really as you understand the end-to-end solution that the robot is operating within that you can begin to uncover the underlying failure modes that leads to those excessively high autonomy exceptions. And one other point I want to make about this stage before we move on is that at this stage, it can be really tempting to build up a lot of homegrown or dark ops support tools. And those have their place. They're actually really important to accelerating problem response at the very early stages. But be careful not to become overly reliant or allow those things to become mission critical if they can't scale with your operation. The very worst case possible is that you're ready to move on to the secondary stage, your solution is ready, your people are ready, your customers are ready, but you realize that your support infrastructure can't make that leap with you. Okay, moving on to the secondary stage. We're off the ground, rocketing towards the atmosphere. Drop those boosters. We've got 500 robots we want to deploy. 500 robots, that can feel like a lot. At this stage, just keeping up with growth is your dominant challenge. You know, I was talking about the challenges of your support infrastructure, not being overly reliant on homegrown tools that aren't ready to scale. This is where good decisions earlier in that primary stage really you start to reap the benefits of, or you start to suffer the consequences of bad ones. As the number of robots in production grows, your engineering team is probably going to take more of a back seat in day-to-day operations because problems are better understood and solutions or workarounds are better understood. That means more reliance is placed on your operations team, whoever those people are, remote or on-site, who are responding to all of these autonomy exceptions. At the same time, number of robots are being deployed very quickly, and so you have large increases, 5-fold, 10-fold in the number of robots in production, and that means you're starting to see new problems that you didn't see before when you just had fewer daily hours of operation involved. At this stage, operating costs also can start to become a problem. Remember that $30K a month just to respond to autonomy exceptions earlier? If you haven't managed to break the linear relationship between autonomy exceptions and deployed robots, at 500 robots, that 30K has grown to 300K a month. That's over 3 million a year just to respond to these autonomy exceptions. That should be a scary number considering how small of a piece of your overall support infrastructure just autonomy exception response is. In this stage, you'll need to build on all of the momentum that you established during the primary stage, leveraging your systems thinking and understanding the end-to-end solution, right? But with engineering taking a back seat and operations really coming to the forefront, fast feedback loops, which are the second RobOps principle, are especially important. Fast feedback loops or amplified feedback loops are the idea that any learning in any given situation is captured and communicated to the people or organization that needs to know about it as quickly as possible. And this can manifest in a few different ways. For example, a navigation problem observed by a member of your operations team, capturing the circumstances of the navigation problem, all of the logs and diagnostics needed, and communicating that to a navigation engineer quickly so that a fix can be developed and deployed. It can take the form of an operations team member who has the wrong process to respond to a given incident or autonomy exception. That problem being identified, communicated to ops leadership so that training and documentation can be updated and correct that action. It can be your frontline employees, those who have the most contact with your customers and the best opportunity to gauge customer sentiment. Having the right methods and channels to communicate that customer sentiment back to sales and product so that it can be incorporated into future planning. Key outcomes of fast feedback loops in this stage are growth in process improvements and standardization. These are critical steps to enable you to hit the levels of efficiency you need to return robots to production faster, which maximizes the value that you deliver to your customers. In the primary stage, it can be pretty common to have different methods of responding to different problems. And that's natural, it's okay. It's a part of finding the one best way to respond to any given situation. In the secondary stage, though, that can become problematic. And you really need to focus on the one best way. You probably have one best way for most problems you're going to encounter at this stage. And that one best way is the most reliable, the most effective, and the most cost-effective way. And it's important for you to consolidate your teams down to that one best way. I learned this lesson previously. I was the director of remote operations for a robot as a service company. And I got a call one day, and one of our robots had gone somewhere it shouldn't. And that in and of itself, doesn't sound like that big of a problem. But in this case, our robot had gone into our customer's women's restroom for their customer. Not ideal, obviously. So how did this happen? Well, as we dug in, we found out that one of our remote operators, someone on my team, had relocalized the robot, and in doing so had made a mistake and set the pose incorrectly. And as we tried to understand why this happened, we learned a few things. So what did we learn? Well, we learned that our feedback loop was not very effective. we were relocalizing robots a lot, and we weren't communicating this back to engineering in a way that set the priority for that to get addressed and fixed, and the fix back out to production to reduce the frequency of this. So we had a very error-prone situation due to all of this activity on relocalizing robots that we weren't addressing. We also didn't think through and understand the risks inherent in manual relocalization, taking the environment into account. We didn't think about, well, what if we did this wrong and the robot was aimed at the restroom? Our systems thinking was incomplete. Okay, so moving on to the next stage of the journey. We've escaped the atmosphere and we're into orbit. How do we survive up here? In the final stage, any remaining inefficiencies become glaring problems. Remember that scary 3 million annual burn rate for remote operations? At linear growth, if you haven't broken that linear relationship between your robots and your autonomy exceptions, you're not burning 3 million a month. That's clearly not sustainable. In addition to operational costs being at risk of going out of control, your engineering and product teams at this stage need to be focused on the next solution, right? It's keeping you ahead of your competitors in the marketplace. And so there's a lot of pressure on your operations team to maintain performance. Meanwhile, at the same time, your success in the marketplace means that you're adding more customers and more robots and further adding complexity into the environment that you're supporting. And while it's important in all aspects of the journey, the third RobOps principle really here comes into play. That's called continuous learning. And a lot of you are probably familiar with continuous learning in terms of software development, CI/CD pipelines, and that kind of stuff. But it's really important throughout the company, but especially in operations at scale. In order to get your costs under control, you're gonna have to take a hard look at your operating model. Right? What things, what aspects of your operation were valuable in the primary and secondary stage because you were learning. But now in this final stage, you're no longer learning from those aspects of your operation. They've become just overhead. Are you focused on the things that are your core competencies? Or are you continuing to operate in the same manner because it's the way it's always been done? So in this final stage, staying laser focused on how you add value to your customers is key. It's a litmus test that every aspect of your operations needs to be evaluated against. And where you aren't adding value, find a partner who's best in class in that area. They're out there. Okay, so today we've talked about the exercise of scaling from 5 to 50 to 500 and even 5,000 robots, and how the RobOps principles apply to those different stages and the importance of breaking the relationship between the linear relationship between autonomy exceptions and robot deployments to manage your costs. And often when I'm speaking with customers, this is where someone will ask me, they'll say, John, when's the right time to bring these principles into play? And it always reminds me of an experience that I had last year. So I was the director of remote operations for this robot as a service company, and I managed a remote support of all of these robots. And we had exited the secondary stage into the final stage. We had over 500 robots deployed with plans to get to 1,000. But we knew that our remote support costs were unsustainable. They could not scale with us. It was too linear. And so we had identified a partner who we felt was best in class in this area, and had a 3-month transition plan in the fall to move some of the more repeatable, less core competency work over to them at significantly reduced costs. And then a global pandemic happened. And that 3-month transition plan in the fall, because of cost pressures due to the pandemic, became a 1-month transition plan right now. However, we were able to be successful. We did transition in about 1 month. With very little disruption to our operation. How do we do that? Well, we did that because our systems thinking was sound. We had really focused on understanding the end-to-end operation of our solution, and we knew where the failure modes were, so we knew where to focus our attention to prevent any catastrophic problems. Our feedback loops were really tight. Operations and engineering were working very closely together to observe problems, report them, get a resolution, and get it back out. And that was working really well. And we had kept learning. We kept finding new incremental ways to improve how we operated so that we didn't miss any opportunities for improvement. So when is the right time to implement these principles? The right time is right now, wherever you are in this journey, because you never know when a global pandemic is going to happen. Okay, thank you all. I hope this has been informative. And Florian, back to you.
Thank you so much, John. Really a lot of great lessons earned and learned along the way. Thanks for sharing that with all of us. So a little bit about InOrbit. We basically started a company with this mission of maximizing the potential of every robot. And one of the things we want to do is to help robotics companies focus on their secret sauce. Whereas our secret sauce is really handling the common yet critical infrastructure that every company will need to address. And today we covered some aspects of that. To give you a broader view of what we do, some of our capabilities that we've built to resolve some of these problems go from getting the data necessary for real-time monitoring and interventions, to using data to improve fleet efficiency on an ongoing basis, that continuous improvement that John was talking about, as well as the ongoing operation of the robots as we covered today, and ultimately making everything work together, whether it's heterogeneous fleets, integrations with other systems. Robots usually don't operate in a vacuum. So with that, that's the end of our presentation part. And I'd like to open it up for questions. And again, if you haven't already, feel free to ask over chat, and we'll try to cover as many questions as possible.
Well, thanks, John and Florian, for sharing experiences, war stories, and, well, these fun stories about robots in bathrooms. And thanks for all the questions that you have shared. We'll probably not be able to cover all of those, but we're going to cover some and then follow up, as we mentioned before. I'm going to start with one that is kind of answered by John, but I think it brings an interesting twist. It's, how do we know we are ready to start this process of scaling up operations? And the context that was given is, we already have some robots and we're scaling to 40 robots in 6 months.
Yeah, sure, I can take that one. There's really no time that's too soon to start bringing these principles into your scaling. You know, a lot of the scaling demand is going to be driven by your customers, but bringing these principles into play, into that exercise, are important early because they have compounded. Think of it like compounded interest. The earlier you bring these principles into play, the more value you can generate early, and then you can continue to reap the benefits of those learnings early on as you grow. So there's really no time that's too soon to start. Great
question, great answer, thanks. There's another one coming that says, well, I still do not have a clear picture how the application looks. Practical use cases would help a lot. And on this one, I'm going to give a quick answer. Let's connect and we can do a separate session exactly to cover that question, and happy to do so. We're going to cover that a little bit more in a few seconds. Let me go to another question that we have here, and that one is, we are already at product market fit phase and are starting our path to 150 robots. We got here with our own solution and we're already experiencing some pains around operating our growing robot fleet. How do we get started introducing an operations layer to ensure our service stays up and with stability for our customers?
I think I can take that one, Diego. So first of all, if you're a product market fit, congrats. It's not easy in general, and especially in robotics, getting to that scale is quite an accomplishment. I'm sure you did some heroic things getting here, building your own tools and so on. I think the recommendation at this point would be to really focus on your unique, value and to your customers. And a way to do that is to not worry about the infrastructure of things that all of your competitors also have to worry about, and really rely on a scalable platform that will grow with you. If you got here, I'm sure you're still planning on growing some more. As we discussed, you're on your way to 500, but then there's the 5,000 mark. So the challenges will keep changing, and if you're on a platform that will scale with you and allow you to focus, I think that will accelerate your progress.
Great. Look, I'm going to go through 3 more questions quickly and then wrap up. One comes from a systems integrator, and it says, we're a systems integrator and we're setting up full solutions for third-party logistics type customers. Even though we operate those robots as a service, they need to have some visibility, and they already have other systems in place in their operations. So how do we ensure a solution that integrates well with their current systems and processes, and that can bring visibility to the different players in the chain?
That's also a really great question. I think SIs play a really critical role in connecting the robots to the surrounding environment where they operate, both physically and digitally. So what you really want is a platform that will give you APIs and other ways to integrate with external systems. Usually each robot vendor will build their own solution that's specific to their robot, which are great. But you may have situations where you have different robots from different vendors operating under the same roof, maybe performing completely different tasks. One may be moving pallets from the cargo bay into an area for depalletization. Another one may be cleaning the floor. So I think giving your customer a complete view of their, think of it as a robot workforce. I think that's a great value add that you can provide as an SI. And definitely InOrbit can help with that.
Look, we're going to go through 2 very quickly and then jump to wrap up. Good questions. Thanks again, everybody. One question here, could you talk about what customers expect from orchestration of heterogeneous fleets at scale, challenges they need to meet, and how InOrbit addresses these?
Yeah, let me take that one for a little bit. At scale, customers don't want to buy a robot. They want to buy an outcome. And as your customers have multiple robots operating in a space, they're going to look for cooperation, collaboration, and streamlined interactions between their various automation solutions. So it's really important to keep in mind that all of these solutions are important only in so much as they improve or streamline the production of whatever facility that they're inside of. And cooperation, just like cooperation between people working in those facilities is critical, cooperation between robots will remain critical as well.
Fantastic, John. Fantastic, Florian, as well. And well, we're getting to the time there, but we really hope you have enjoyed the webinar. I have to say that we got way more questions than time to answer those questions, but expect a follow-up from me on those questions and answers. And here you have our emails, so please connect with us. You have all our emails if you have specific questions or interest in a 30-minute session to talk about RobOps with our tech or operations teams. We're geeks about this space and we want to keep learning with you, so please connect. Finally, we want to share with you, number 1, a link to schedule a demo. It's www.inorbit.ai/demo. You can find it in the chat. And you will receive in our follow-up email, other than the thanks for joining, a white paper and, well, some of the information that will be covered from the survey now. So thanks for coming to this webinar and see you next time.